Hi, welcome to this session on analytics and predictions. This is your instructor Kumaran here. In this section, we are going to be talking about a lot of the machine learning stuff, how you use various machine learning algorithms for performing predictive analytics. Just to forewarn you, the concepts that are being we are going to face in this particular session are going to be a little complex. We have toned down the complexity of these algorithms as much as possible for easy understanding. However, if you do feel confused or you do feel stuck, please re-go through the presentations once again and feel free to use other references either on the web or books to cross-check or cross-validate these concepts, because they are in general a little difficult to understand. But we have toned down as much as possible, so I hope this whole session is pretty helpful to you. Moving on, we keep hearing about analytics all over the world, and everybody talks about analytics. But the question is, what exactly is these analytics we are talking about? Analytics, of course, is anything that you do with data, do look at the data in various forms and then try to make inferences and take some actions. But there are a number of types of analytics that you would keep hearing all the time. So just to make sure here we all understand what are the different types of analytics that today exist in the parlance. The first type of analytics is called descriptive analytics, and this is just understanding what happened. This is basic reporting, and anytime you have a report that is coming out, you look at the report and say, okay, I see this is what happened yesterday. Yesterday we made a sale of $1,000, and this week we have been making a sale of $10,000. So today's performance compared to last week was more by 10%. Now this is just descriptive analytics, just looking at and seeing what exactly happened. The next level of analytics is called exploratory analytics, where you're trying to explore and find out why something is happening. So yesterday we see that, okay, yesterday I made a sale of $1,000, which is 10% more than last week. So why was there a 10% increase in my sale? So was it because in general yesterday was a holiday, or was it because I had some marketing going on yesterday because of which there was some increased sale? Or was it, more importantly, was it because where did my new sale came from? Was it from my web? Was it from online sales? Or was it from my store sales? Was it from a specific region? Like, was it mostly from the west of US versus the east of US? So why exactly something happened and where exactly something happened is what exploratory data analytics is all about. Inferential analytics is trying to understand about an entire population from a sample. Now, the population here refers to everybody. Let's say I'm trying to analyze cancer patients in the US. And when I'm doing this analysis, I can't collect data about all the patients and try to work on them. Rather, I take a sample of this population, a few sets of 100 or 200 patients, try to analyze them, and once I get some findings, take that findings and extrapolate that to the entire population. So it's trying to understand a population from a sample. This keeps happening usually when you have drug testing. You test a drug on a sample of people, and then that sample of people, you make sure that it has a nice mix of all types of people, like people of all age groups, people of all ethnicities, equal percentage of men and women, and then you test the drug and then say, this drug works better on men than on women. So you only looked at a small sample, but you're just taking that and extrapolating that to the entire population. That is called inferential analysis. The next level is the predictive analytics, which we are going to be talking in detail in this session. And predictive analytics is about forecasting what is going to happen. We are trying to predict. We are going to use past data to understand relationships between various features or variables and use that past data to predict what is going to happen in the future. Causal analysis. A causal analysis is where you're trying to figure out what will happen if I change one variable. If I change one variable, how is it going to impact the other variable? Suppose, for example, in marketing, we have, let's say, two things. I have price, I have discounts, and I have total sales. So I have price, discounts, and total sales, and I'm trying to understand how will my total sales be impacted. Suppose I change the price of my product by $20. How is it going to impact my total sales? What will happen if I give a discount of 30%? How is it going to impact the sales? I can also analyze for various slabs of discounts like 30%, 40%, 50%. When I do these discounts, how is it going to impact my overall sales? This is called causal analysis. And the final thing we keep hearing is what we call deep analytics. Deep analytics is really not a type, it is just a term that is being used in popular paradigms, where it is the use of advanced techniques to understand large and multi-source data sets. And deep analytics involves any of these other ones we talked about. It will involve exploratory, inferential, predictive, and causal kind of analysis. In general, deep analytics is like an advanced level of analytics that you do. Let's look at what exploratory data analytics is. In exploratory data analytics is one of the first steps you do once you get your data into shape, and that main goal of the EDA is to understand the predictors and targets in the data set. You want to understand how the predictors look like, how the targets look like, what are the relationships between the predictors and the targets. How are the predictors correlated with the targets? How are each of the predictors correlated with each other? You try to look at the relationship between these variables and try to understand how when one goes up, does the other also goes up? But like one goes up, the other does not get impacted at all. You try to understand these relationships when you do an EDA. It is used to uncover patterns and trends, which is again the relationship between these various variables. It is used to identify key variables and eliminate unwanted variables, which is you look at typically a data set coming in, there are like 20 different variables and there is one target, and you want to make sure that you want to look at these predictors and see which are the ones that are highly correlated with the target and which are the ones there is no correlation with the target. And what you want to do is, if you see certain variables that does not have correlation with the target, you want to eliminate them. Why do you want to eliminate them? Is because even if you pass these variables to a machine learning algorithm, the machine learning algorithm will simply ignore them. But it has to spend a lot of time and resources. The machine learning algorithm has to spend time and resources trying to work on these variables and understand its patterns, which means it is going to take more time and more CPU power, more memory and stuff like that for it to execute. Plus, if you are using a big data set, a huge data set, you have to also store these unwanted variables in a data store and stuff like that. So you can eliminate all those unwanted costs if you find out ahead of time if there are some unwanted variables and you just want to eliminate them. It is used to detect outliers. EDA is also used as a great tool for finding out if the data contains some outliers and whether you want to eliminate them or not. It is also a tool to validate if the previous data ingestion process has possible mistakes. So when you do a lot of data processing, you can do a quick EDA on the final results to see that the data looks okay. What do you mean by data looks okay? Is that as the data ingestion process, does it have any bugs because of which it has introduced some unwanted data, or when it is trying to do some data transformation, it did mess up something and stuff like that. So you can do those kind of analysis using EDA, and it is pretty simple and straightforward to find out. Suppose you are doing a date transformation, suppose dates are coming in various formats and you're trying to convert all these dates into a proper format. And now that logic might have an error, because of which it always puts the date to be date 1. So instead of putting the actual date, it may put date as date 1. If you do an immediate analysis or immediate analysis of by day kind of an EDA analysis, it will immediately tell you, okay, all the days are 1, so what happened to the dates? So you can go back and look at the data and see why things are not happening as it is expected. It is used to test assumptions and hypotheses. So you typically have a lot of assumptions that you make, or hypotheses you make as to what is happening. So suppose as your sale went up by 10% last week, and immediately people are talking about, I think the sale went up because we made good advertisements, or I think the sale went up because a particular region performed a lot better. So people start making these assumptions and our hypothesis, and EDA is a great way to go and verify and validate if the hypothesis is true, or is it valid, why exactly certain things are happening. The tools used for EDA are the tools we have already looked at, or we would be looking at as a part of our class. So correlation matrices are one of the most primary tools for EDA. We would be using that in all our use cases to look at and understand how the data looks like. Box plots tells you the variations in the data that is coming in. Scatter plots lets you analyze the relationship between two variables. Principal component analysis helps you understand. Principal component analysis is an automated way of looking at your data, taking the variables with high predictability and throwing away variables with low predictability. So it is a good automated way of eliminating unwanted data. Histograms, of course. Histograms again are a great way to look at data and understand the trends and patterns. Thank you.